lecture. So good morning again on our next lecture on research on safety and comfort of means of transport. We will continue with the topic on applications of vibroacoustic methods for analysis of comfort and safety of means of transport. So you already know what are the phenomena and how its vibrations and noises generate during the movement of the, for example, vehicles, but different kind and different types of the means of transport. So today I will try to show you the first approach to applied of vibroacoustics method for research on safety and comfort of means of transport. So today we will focus on the acoustics, signals and noises. Okay, so first, if we are talking about the research on safety and comfort in means of transport or any other technical objects, we have to set the goals, yes? We will set two different types of goals because the master course is also important part and the first stage of the scientific path, yes? So we will set the scientific objectives and utilization objectives also. So first, what can be set as scientific objectives of this kind of study? The study of phenomena affecting the safety and comfort of driving a car, for example, a car with vibroacoustics method. So it is the first goal of the scientific research. The second is identification and classification of diagnostic symptoms of the basic of signal processing for noise and vibrations. So today we'll focus more on the noise, and we'll focus on analysis of using of vibroacoustic signals. It will be acoustic signal today to find out the symptoms of the technical condition of the mean of transport, which can be considered as the factors or measures of comfort or safety. It's up to us how we will set the range and the we can say the levels which is alarm level when we are considering the safety or comfort factor. But we have to always remember that not just scientific objectives are important, but these are important because it shows you the new area of knowledge which can be applied for the applications. So we will also set the utilitarian objectives, which focus on possibilities of using this method, this research into the in situ conditions, in the real conditions, in the real research of the means of transport. So how it can be set as develop test procedures, mathematical algorithms, software, and the concept of prototyping test device. So it is how we will go through next TRL level from the pure raw knowledge into the pure raw application, which is the final device for testing of the comfort and safety when we are talking about the means of transport. So it can be the first goal. The second is more overall goal. It is not just the engineer goal, but more society goal. Yes, to all of us is improving road safety, which is the realization of one of the priorities of the European Union transport policy, because one of the most important area when we are talking about the transport policy, it is the safety, and especially it is extremely important issue when we are considering the road transportation, because the road transportation is a source of most important and most highest numbers of the accidents. So that is how it is important to secure the safety of the road transportation. Of course, we've got different issues important for the transport policy, and one of those is also the environmental impact. So if we will consider the environmental impact as important issue when we are talking about the transport policy. The vibroacoustics method are also very useful, especially the research on the noise of transportation, because transport systems are considering as the most important factors and generators when we are talking about the noises. Yes, so also if we will consider not just safety but also the safety of humans, but safety of environment, the research on the noise generated by means of transport are very important research. So these are just examples of different goals of investigations of research set into two different types, as the scientific and utilitarian objectives. And I would like to also strongly recommend you that you are on the level of study when you are trying to improve your scientific skills, and it is good if you will be able to understand exactly what different knowledges and what new areas are you able to study when you are representing the scientific approach to the research. But also, as the engineer, you have to also remember about the applications. So if those methodology and those knowledge is applicable for the real life, if yes, you can consider it as the new knowledge for new devices, new technology, or new knowledge to set the policy to improve the safety or the environmental impact of transportation. So it is how you should consider the vibroacoustics research on safety and comfort, not just as the final results for the testing of device, for example, but also overall goals. Okay, so what are vibroacoustic signals? I already mentioned in our previous lectures what are the vibrations, what are the acoustic signals. So right now we'll talk as the total signals of vibroacoustic signals. So if you would like to imagine what is the vibroacoustic signal, you should consider the distribution of the values of signals, values of vibrations, of values of acoustics pressure, sound pressure or sound level in a distribution of the time. When we are talking about the time distribution, you should call it the waveforms of the vibrations or of the sound, or in the frequency. And if you are talking about the distribution of in frequency domain, you are talking about the spectrum of vibrations or of the sound or acoustic signals. So when we considering the vibroacoustic signal, we are looking at this distribution as the source of information, as the source of symptoms. Yes, everything which is not usual, you should test it a few times and try to find out if it is a useful part of the signal, and if this part of the signal discovers some information. So to do it, it is good to apply proper methodology for the waveforms analysis, but also proper methodology for the spectrum analysis. And if we are talking about the stationary signals, which are not changeable in the time, the good enough methodology is based on the time analysis or spectrum analysis. But if we are talking, then mostly we are talking about the non-stationary signals. When it is not it is changeable in the time and in the frequency, you should use the time frequency representation of the signals, which is shown on this image. So acoustics or vibration signal as the results of change which occur in technical system or associated processes is a medium of the vibroacoustics information. So what is important, that the vibroacoustic signals should be considered as the medium of the information. It is the first important note. As the information, we understand everything what is used to get more efficient selection of leading operations or to specify objective. Yes, so it is what we should consider when we are talking about the engineer approach and signal processing approach to the information. So we are looking for the more efficient selection of the symptoms and of the information covered in the signal. Information is related indissolubly with the signal because the signal is the medium of the information. So it is the first assumption which I already give you. It informs us about conditions, changes or processes of physical or technical system taking under consideration. So it is also important part of the investigation and on the research to first separate what are the mechanism of the signals. It is mechanism of the signals based on the physical phenomena, or it is based on the environmental impact on the signal. So it is also important part of the investigations. Vibroacoustic signals have the biggest information capacity, which is probably the most important profit and advantages of the vibroacoustic signals, which enables to observe changes in wide frequency range, of course based on the frequency sampling during the recording the signal. That is why the vibroacoustics research method are used in wide application in technical object diagnostics. So right now we should say that vibroacoustics method are very popular use when we are talking about the diagnostic or structural health conditioning, because there are unwanted effect of the technical system, so we can measure it, and it is non-destructive methods to check, to register the information of the object. So it is probably the most important benefits. Vibroacoustic research organization. Of course, we can set different organization, different plan of the research, but I will show you this one which should be clear for you and which should show you the directions of the research. So let's start with the main goals. Yes, so as we already said, the main goals should be divided into scientific knowledge and applications. So to set the goals, we have to establish, based on the goals, yes, already said, we have to establish the research. Then we have to prepare the research plan, including scope and methods. Then we have to conduct the research. Then we have to analyze the results. Then we are able to find some conclusion, to find some knowledge, to set the symptom. So it is the proper way, the proper path of organization of research of vibroacoustics method. But you have to check at least twice and always set the feedback to control if you are still on the scope of your goals, or you have to change something, because in many situations it is new knowledge and you don't know everything about the phenomena you are researching on. So you have to also set the feedback between the each operation. So it should look to. So we've got the verification after each step of the research, yes, and we can verify it, first of all, if we are on the direction to follow with the goals, or if we have some problems with our research. Then we are able to move back with one step in previous operation and improve our research. So it is overall idea how you should conduct the vibroacoustics research, and not just vibroacoustics research, but any other research when you are expecting new knowledge. So verification after each step and proper organization of the research. So it is the main idea. Okay, so what could be the plan and scope of the research, which is the first part of the investigation, as you already know. So if we are talking about the vibroacoustic research, it should cover at least two most important scope of the research. So first is the acoustics, So if we consider the means of transport, the vehicle, the motor vehicle, we can research the acoustics, apply the acoustics method to research on the tires, for examples, of exhaust systems or engine. Another scope of the research is on the vibrations. So we can use the vibrations to test the suspension in the terms of comfort or safety. We can research on the floor panel vibrations in terms of comfort and safety, mostly in comfort. And we can research also the steering system, which is extremely important when we are talking about the safety as far as suspension also. And we can consider the steering system in terms the research on steering system in terms of comfort and safety. So these are the two main areas on scope on vibroacoustics method, and these are the example when you can apply the vibroacoustics method and what you can research based on those devices, for example. So today's lectures will be focused on the acoustics methods, acoustics research on tires, exhaust systems, and engines. So I will just show you the few examples of my own research, so you will be able to see how the innovations methodology and innovation method on research on safety and comfort can be applied. Okay, so as I already mentioned, today we'll talk about the acoustic research. So the first is example on research on the noise level of the tire. So probably one of the most common research on the tires you will find is research on the noise generated by the tires, and it's starting to be even more important every next year. So right now we've got even index on the noise level. So this is the example of the simple methodology and system measurement system for the measuring the sound level of the tires. So we've got the measurements instrument, which is the Son 50, which is the sound level measurement unit. Yes, but I did use not just the microphone and decibel scales, but I did also record the raw air pressure from straight from the microphone. So I did have also the waveforms of the sound pressure, not just the sound level. So of course, if we are using the analog device, we have to also use the data acquisition unit when we are changing the analog signals into the digital system. So these are the example of the data acquisition unit. So when we are applying the vibroacoustics methods, mostly you will have to have the data acquisition unit also, and of course some PC computer or the laptop. It is, as you can see, the very old one, when you will be able to monitor the results and conduct some investigations and signal processing method. So what is the main idea and the and the main trigger of the research is that the noise of the tires is extremely important factor when we are talking about the noise of the vehicles, which can be considered as the comfort factor for the drivers, but also to the any other humans around the vehicles. We've got the analog digital converter, yes, and we can analyze the signals, the time realization of the signals, not just the level of the vibration, and we can find out how much more information is covered is in the waveform of the air pressure, not just the sound level pressure. So you will see some results. So the conception of the research. So research plan. So we know what we are looking for. So how we will do it. Yes. So what was the concept of the research? So I was thinking about the research based on the typical stance to research the tires, which is the first when we've got the big wheel and the small wheel, which is a tire, and by generating the movement of the big wheel, we are also running the tire, and we can investigate the phenomena in the contact area. Another concept of the research device and the research test was to cover the space around the tires with the microphones to measure the sound level measurement system. Yes, so it was the main idea. So I did design, and my students built the test station, which can be seen in our laboratory. When we've got the simulation of movement of tires on the road roughness, we can even change the structure of the gum, which will show you the different roughness properties. Then we are able to set the different pressure and different force, vertical force also can be changed, and by changing the position of the measurement unit, as you can see, we are able to measure the sphere around the tire during operation when the noise level is generated by the movement of tire. Yes, so it is the idea, and it is how the research was conducted. Of course, the first important factor of the research was to isolate others source of noises, and one of the most important source of noises was the engine, the power engine. And as you can see, we also created the isolation shields here, which minimize the impact of the noise of engine. But it can be also reduced by the post-processing method. So here you can see the measurement system, here you can see the measurement objects, and here you can see the measurement system with data acquisition unit and the computer to register all signals. So what was the results of the investigation? So first of all, you can see the examples of results of influence of vertical force, which were input into the wheel on the level of the sound pressure, of the sound level. Yes, so here you can see the sound level in decibels, starting from 62 decibel, and the worst situation is 78 decibel. This point 1, 2, 3, 4, 5, it is different measurements points around the tire. As you can see, it is clearly visible how important factor is the vertical force on the generation of the vibration. So if we will consider the different weight of the vehicle, we have to also consider the huge impact on the noise vibration. So it was the first investigation. The second investigation was on influence on differences of the noise generated by winter's tires and summer tires. Yes, so summer tire is the blue one. Yes, so you can see that in each, because we did consider the frequency bands here. The frequency is the octave filter here. So these are the medium of the frequency bands of the next octaves in our filter. You can see that in each frequency band, almost each, not just two last one, which is 4,000 hertz and 8,000 hertz. The summer tires are much less noisy than the winter tires, which are the purple bars here. So, but what is interesting, because probably more of you can easily hear the difference when you are changing the tires, that for some frequencies, highest frequencies, the situation is changeable. So the summer tires generate bigger sound level than the winter tire. So, and it is probably the result of the construction of the tire. So this you can see easily how easy it was to find out the differences by using the vibroacoustics method. Another experiment was about the sound pressure signal for the tire, different tire with different pressures. So we set two different pressures inside the tire. Yes, one was the 100 kilopascal. The second one was the 300 kilopascal, and we did analyze what are the difference. So these are the wave. This is the waveform of the air pressure. So it is not the sound level, it is raw air pressure signal in pascals. So it is the waveform, and this you can see the spectrum, which is the frequency distribution of this noise, yes, this waveform. So this was the results for the 100 kilopascal, and here you can see the results for the 300 kilopascal. So if you consider as the first look on these two charts, probably you won't see too many differences. So that is how I did put both waveforms on one chart. So right now it's easy to see the differences between the green and the red, when the red represents the 100 kilopascals and the green 300 kilopascals. And what is even more important, you can see the differences in the spectrum. So you can see what are the most dominant frequencies when we are talking about the lower pressure and the higher pressure. So here you can see the differences between those two factors. So as you can see, even based on those very simple comparison of those two signals, you can see that the potential of application, when we look the symptoms in the acoustic signals, and it will register not just the sound pressure level but also the sound pressure as the raw signals, that the possibilities of select new knowledge and new information in those signals is much bigger. Another case of the acoustic research was to research of engine noise, and we did use the diagnostic experiment when we had the engine without the defect after reparation and with defect before reparation, and we try to analyze if we can find the symptoms of defects in the noise signal. So first of all, you have to consider the engine as the source of noises, yes, and vibration, of course, but right now we are talking about the noises. So if you will consider the engine as one single device, you can also find the sub-assemblies of the device which are responsible for some component of the noises. So it is the first example, it is the second example, yes, of the generation of the noises. It is the others examples. So right now you can see that each devices of the engine generate different types of sound, and what you are hearing here, it is complex signals which covers all of those components. So first, it would be the best possibilities if you will be able to select all those components, because then you will be able to check the technical condition of each single devices of the engine. But it is a very difficult task, but it was the main idea of the investigation. So we did make it a little bit more simpler. So first of all, we set the measurement points because it is important part, especially if you are looking for the component of the noise of the selected device of the engine. So as you can see, it was the tested vehicles before and after reparation, and we set the universal sphere of measurements which were exactly the same before and after reparation, and for every single vehicles we did test it. So we had 5 measurements points, every of those measurement points was in distance 10 centimeters, yes, and every point was choose for different types of the components of the signals we did expect. So what was the results? So these are the photos which shows you exactly how the research was conducted. So this is the vehicles with the engine. Yes, the cover of the engine was always open, and it is the first measurement noise, the second measurement noise, the third, the fourth, and the fifth is in opposite way. So these were the visualization of the research. So right now results. So before, if we will compare just before and after repair. So these are the examples of the results. The black bars are before repairs. The lighter are after research, and it is just simple measure as the equivalent sound pressure, sound level. I'm sorry. So we've got the decibel scale. So as you can see in measurement point number 1, before reparation, the sound level was more than 74 decibels. Yes, but after reparation, the same measurement points, we've got the measurement sound level around 67 decibels. So as you can see, it's 7 decibels difference. So if we are talking about logarithmic scale and decibel scale, the 7 decibels is the huge differences. And in each measurement point, you could see the differences before and after reparation. So what is the first conclusion what we can say? The first conclusion is that after reparation, so not defected vehicles generate lower sound level, so it is good for the environment. Yes, but what is when we are talking about the symptoms of the diagnostics, we can say that probably the source of defects was located close to the measurement point number 1. And if we will consider what devices are located in this measurement point, you will be easily to find out what was wrong. Yes. The other example is to compare the before and after sound level, but again in the octave scale. So it is the frequency, middle frequency bands for the next octave, and you can see that in each case the sound level for each band is lower after reparation. Yes, but what is important, you can find out in which frequencies the differences before and after are the biggest. And if you will follow those frequency, you have to consider what devices are working during control conditions in such speed, which is the frequency also, and you will find out easily what devices was defected before reparation. So it is very important also the second stage of the investigation. So first you are able to find out about the location of the defect. Second of all, you can find out which devices which devices could be defected, because these are the frequencies band which are most sensitive on the defect. So these are the example how you can use the acoustic signals in the research on technical conditions. And of course, if we will go further with the analysis, the technical conditions of those devices is extremely important for the safety and comfort. So another examples is it was the research on exhaust systems measuring point, and it is two directions we can say research. First is about the volume of the noise generated by vehicles, which is extremely important for the environmental impact of the transportation, but also we could consider the volume of the measurements as the symptom of the diagnostics. measures when we are considering the technical conditions of the exhaust systems also. So it is two directions. So we set the different measurement points. So starting from the beginning of the exhaust systems, something over there, we set the 4 measurement points here, and also the last one on the end of the exhaust systems when we also check the condition. That is how we was able to locate the defects on the all way from the beginning of the exhaust system to the end of the exhaust system. So these are the photos of the research. As you can see, again, the sound level pressure located in different measurement points, and we, of course, the highest, the high of the measure is different because the exhaust system is lower than engine. Okay, so what was the results before and after repair? So we knew that the exhaust system was damaged and it was repaired. So before repair, as you can see, it is the black bars. In all 5 measurements points, the value before reparation of sound level is much bigger than after reparation. And again, you can see that in the second measurement points, the differences is the bigger one. So we should expect that the defect is located somewhere here, somewhere there. And similar, we are going into the analysis of frequency distribution and octave filters. And you can again check what are the differences in each frequency band, and as you can see for these 2 frequency bands, these 2, yes, the differences is biggest. So that is how I should look for the devices or the elements of the exhaust system which were defect based on the analysis of such dynamics. Yes, so 250 frequency and 1000 frequency. So it is again the same situation, and you can easily see how clearly you can find out the symptoms in the measurement system. And we are talking just about the sound level, not about the pressure, air pressure measure and the raw signal. Okay, so I think that it would be everything for today, and right now I would like to invite you for a short discussion. Thank you very much.